Okay, so this formula here is what we'll use to find the length of a curve, where we have an integral with limits a and b, and the formula is always like this. It's a square root 1 plus. In here, you drop in the derivative. Always square the derivative and then dx. Now, sometimes it's dx, sometimes it's dy. For this particular problem here, since x is the function in terms of y, we know that it's pretty much going to be this formula, but it's going to be a dy there, and instead of x's is going to be y's. And even the numbers are going to be y values. Like right here, for instance, you see our limits are from 1 to 4. Those are y values. So the first thing we need is to find the derivative. So this here is our derivative, because the derivative of x is just x prime. Let's just call it x prime. Y, square root y is the same as y to the 1/2. The derivative of that should be this. And then here, derivative of that should be this here. If you go that times that, you subtract 1 from that, that should be the derivative. So now let's take the derivative along with our integration limits, and let's drop them into here, into this formula. So here we are. We have our integral from 1 to 4, and then all this gibberish, that's the derivative, and then we have dy. So before I actually square this, I felt like rewriting this. So the negative 1/2 power is just the square root in the bottom, and then that's just this here. So now I have to take this binomial and square it. So to square means to write it twice, and to, of course, expand it as such. And if you do that, here's what we should get. So this is what we should get here from this expansion. It's very sneaky, but we should get these 3 pieces. When you do that and combine like terms, that's what it should be. And let's see, 1 minus 1/2 is 1/2. I put that in the front. This is in the back, dy. So I factored out a 1/4 from here, here, and that's what's left inside. You can verify this because if you distribute the 1/4 there, you get back the thing before. And this is why I took out the 1/4, because I can actually square root the 1/4 to get 1/2. And because it's just 1/2, I kicked it out to the front, and that makes the integral less messy. So now I have just the square root of this stuff here. Now, you know how this is a fraction and this is not? Why don't we get common denominators? So I got common denominators with everybody. Now they all have the common denominator, so I can just add these 3 thingies into one piece. Yeah, so now I'm dealing with 1 fraction instead of 3. And if you notice, the numerator can actually be factorized, right? So this is actually the factorization of the numerator. Now I have a square root of a fraction. I can actually split numerator and denominator and give each one its own square root. And then I can nicely square root the numerator. And then what I can do is I can take this fraction and split it up into 2. And then I can simplify this here. So y divided by the square root of y, if you simplify that, it's just the square root of y. Now, instead of radicals, let's write these with rational exponents. And now we can actually find antiderivatives. So let's find the antiderivative of this and this by adding 1 to the exponent and dividing by the new exponent. Do that to both of these. So I added 1 and divided by that new power. I add 1 to that, divided by the new power. We're going to go from 1 to 4. Notice the integral symbol disappeared because we actually took the antiderivatives. Now, before we do that, why don't we just clean this up here? And now we can finish by plugging in 4 and 1 into this and this respectively. So we plugged in 4 here, boom, 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 subtract. We plugged in 1 there, boom, 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 subtract. If you actually type all that into a device, you're going to see that we get a final result of exactly 10/3. So the length of this curve here, the length of this curve from y equals 1 to 4, all this math here, it all gave us an answer of 10/3.